needed to pin out information content from what they were saying.
Yeah.
So we
Yeah.
didn't go into that because there wouldn't be enough words in that
You'd
segment.
just be like, it.
exactly.
Yeah, you got it.
Positive or negative.
Yeah, you need someone here to capture the words.
Sure.
So I just have a question about like your data collection. So, for example, you guys chose like energy in one's voice, or skin temperature, or heart rate, which is reasonably you could say that it could correlate with somebody's mood. What is to choose those highly like probable correlation of that data, of those sets of data? So like, let's say I'm trying to collect another set of data for another neural network,
Yeah.
and relating like a country's economy to like something very relatively uncorrelated, like how many lakes they have, or
Yeah.
something like that.
Yeah.
I'm not like I can't say like one data set's better than the other, but like what are the results to something that's highly uncorrelated, and you're looking for some type of correlation to a data set that, between heart rate and tone of your voice to determine one's mood.
Well said.
What are the different results in that, and why did you choose? Well, it's obvious why you chose one, but if you did choose another data set or highly uncorrelated things, and you're trying to find some type of result from it.
Yeah, but thank you for bringing that up. So really there's two kinds of things that end up happening in the machine learning community, right? The first one is, I would say it's a classic study design, which is what we showed you here. Tuka and I had a hypothesis. It was very simple. I think I can take measurements from your physiology and something from your voice, and I can figure out how you're feeling. Well, yeah, makes sense, right? I mean, because we all do it in this room, right? So some piece of technology, if you position it the right way, should probably be able to handle that. That's a very classical approach to a scientific problem. What you're talking about is data mining. It's a fishing expedition, right? So you have an existing set of data, and this is oftentimes for those of you that are graduate students in the room is what we have to deal with. I had to deal with it in my graduate studies, right? You're provided a data set, and they're like, make magic happen. Right? Find something. Yeah, find something, right? You find 3 things, you get a PhD. You find 1 thing, you get a master's, right? That's the trade-off that you're doing, right? Yeah, seriously, right? And so the difficulty is this. You have to be you're your own watchman, right, when it comes to these things. Because the truth is, you can mine data, and you can find the relationship you want. There's a script on my GitHub, which when I'm sharing the code with you, I'll also share it. You'll see that on my GitHub page, where I show you that if you want to be a cheater in science, it's trivially easy. And you can even do everything technically correct. I have a data set with smoking, for example. Okay? And what I wanted to show was that smoking had no effect on your blood pressure, let's say. So here's what you do. I have a smoking data set. What I do is I just keep recutting the data and fitting the same model, exact same model. I just keep recutting. And eventually, I can get a model that says, just by randomly subsampling it, that says, oh, actually, if you're a smoker, it improves your blood pressure, right? I can find that result in the data if I'm being dishonest with it, just by torturing it like that. So the tricky thing with do the number of lakes in the country predict, the economy, what the classical statistics community says you have to do, and nobody does it, unfortunately, in machine learning, is something called a Bonferroni correction, which some of you might be familiar with. So what that means is every time I do an experiment on this data, so let's say I have the lakes data set, like you said, and I say, well, I really need to show for my supervisor to be happy that these lakes are correlated with the economy. So you do one experiment, and you don't find it. You're like, oh, okay. Well, now in order to show that that relationship is true, the results have to be twice as statistically significant, because I already did one. Okay, you run it again. Oh, that didn't work. I still wasn't able to get it. Okay, now if I want to do it, it has to be 3 times as significant. So you're making it harder and harder to hit the target every time you play the game. So unless you're very good at gaming the system on the first time, right? Sorry. So you see, that's the way they classically try to defend themselves. But by the way, nobody's going to ask you about that from my own. They're not going to say, oh, did you Bonferroni correct? Did you do one experiment? Because in the papers, you're going to ultimately report that one experiment that worked. So you're your own guardian, right? So when it comes to those things. I don't know if that answered your question.
That's.
Yeah.
Would you want to talk a bit about your other project?
Connect?
Yeah, and your startup and the EEG signal database.
Which one? The database, sorry?
The EEG signal database, I was told by a double E major friends that their lab built the world's largest database for EEG signals.
Oh, that was my PhD work, had nothing to do with this, yeah. And it was significantly more boring for the record. Yeah.
Anyway.
No, so just a quick overview. Okay, well, I'll give you two pieces, two things for you to look at as per your request. So the first one I think I already showed you.